Hello, everybody, and thank you very much for joining this talk about Citus on Kubernetes. I hope this topic gets you excited because I saw a lot of demand, a lot of users wanting to use this fantastic technology for scaling out Postgres on Kubernetes. So this talk, we're gonna discuss a little bit why you want to run a database on Kubernetes, how this was done to run Citus, to create Citus clusters, before Patroni 3.0 appeared, which is a great novelty, which makes the process much simpler. And the most important thing, how you can run Kubernetes, Citus on Kubernetes today with open source software in a very, very easy manner. So to get started and with a full live demo, this we're gonna be talking today. So please bear with me. Let's get to it. So let me introduce myself first. My name is Álvaro Hernández, or Álvaro in Spanish. I am the founder and CEO of a company called OnGres, which means on Postgres. You can guess what we do, right? I am myself, have been using Postgres for more than 20 years as a DBA, database developer, administrator, trainer, you name it, right? But today, I like to focus more on R&D, on doing what really innovative, new, important things, new development for the Postgres ecosystem, which is the very best thing that you can get out of Postgres. I typically speak a lot about conference. I'm very pleased to be on this one. You can go on my personal website if you want to see all the recordings and slides of all my talks. There's been like more than 120 in the past decade or so. And also want to be involved in the Postgres ecosystem. I founded a nonprofit foundation, the Fundación PostgreSQL. So I'm deeply involved with Postgres. So let's get to Citus on Kubernetes. And here's the agenda for today. We're going to talk, as I mentioned before, a little bit about why you may want to run database on Kubernetes, but this is a whole separate topic, so I'll just give some highlights. And then we're going to look at the existing solutions for running Citus on Kubernetes. What are the available software that you can use? Then let's look at the evolution or the history, how you could run Citus before on Kubernetes. And by before, I mean before Patroni 3.0, which is a significant notable change. And then how you can do a soft today, which the good news is that has become very, very simple, very easy to orchestrate all the components that in reality you need to run a Citus cluster on Kubernetes. And then let's do a demo to prove it all. So why would you want to run a database on Kubernetes, right? Again, this is a very long talk. There's some pointers, some links that I would recommend you to watch on these slides. But the key takeaway, the first reason is if you're all into Kubernetes, your database must also be part of that equation, right? If you have decided that you want to go to Kubernetes because of the many reasons that are, and I'm not going to discuss them here today, but there's many reasons to go to Kubernetes. Then if you leave your database separate, you're neglecting most of the advantages that you may get from moving to Kubernetes, right? So because I've seen this trend, a lot of teams that just move all the applications to Kubernetes, but not the database. Then again, you're neglecting the advantages of moving all Kubernetes. So if this is your way to go, if you want all Kubernetes, then your database should follow with you too. But the other reason is that Kubernetes is an API that hides away all the infrastructure behind you, right? And this allows you to automate deeper that you may get through other environments, being on-prem or software as a service, database in particular as a service, because it's a much richer API. You can automate more operations, particularly interesting day two operations for a database. Then obviously it's also potentially cheaper, for example, than a managed service. Because you just pay for the instances, but you also don't get all the difficulties from doing it on bare instances. So it's kind of the best of both worlds in this regards. And also, last but not least, it's also more flexible because you have your own environment. You're a super user typically when you run on Kubernetes, and you can install any extensions that you want. So it's essentially the always best preferred Postgres environment that you wanted to have, but without the extra cost or the limitations you may find on some of the software solutions for running the managed services for running Postgres, which are great in their own way, of course. But this is a different, significant approach. Again, there's a couple of links I would recommend. A post on the news tag discussing why the database Kubernetes is going to revolutionize the way you run databases, and then a specific talk I gave recently about this topic too. So, what does the software landscape look like for running databases on Kubernetes some time ago, some months ago? And I know this is a little bit of a sad story, right? But the landscape was not big. For testing environments, well, actually there was a few, there's still, of course, a few Helm charts here and there. They're for very basic deployments for Citus on Kubernetes. I was not naming here because they vary in terms of quality, evolution, but in general also because they're quite basic. They're just the Postgres containers spiced up with the Citus extension, and there's a lot of work on your end to make it a fully working test environment. And I was saying it's a bit of a sad story also because Azure Arc data enabled for Postgres, if I named the name correctly, had support for Citus and was apparently deprecated on September 2022. I don't know the full story behind it. I'm just based this on public sources of information I got, but it's no longer available. So some time ago, there was few solutions for running essentially Citus on Kubernetes. And what's interesting is that there's been a lot of user demand for it. If you go to the Citus repository on GitHub, because Citus is fully open source, you will see that there's an issue called Kubernetes support that was open in 2016. It's already 7 years ago, right? For people asking for this with a lot of comments, a lot of people demanding the support. Even Citus themselves, on the recent blog post where they announced Patroni, Alexander Kukushkin, the author of this blog, mentions that they are waiting for Kubernetes operators to introduce or add support for Citus clusters and make it seamless to use through the capabilities of Kubernetes operators. The good news is that we listen to this, and there's an open source project which I'm behind called StackGres, which is a stack of components on top of Postgres that essentially brings not only Postgres on Kubernetes, but also Citus on Kubernetes. And we will be talking about this today. This allows you to use it for testing environments where there is kind of an, I don't know if I would call it official, but there's a Helm chart written by Citus team members as part of the Patroni project. Patroni, the high availability project for Postgres, that is meant for testing purposes, and that's good. You can also use the StackGres, this open source project that I mentioned, for testing purposes. But in terms of production, there is, as I would say, StackGres as the only option that fully supports Citus. It's been supporting Citus from some time ago, but now adds new capabilities through the use of Patroni 3.0 and a dedicated environment, I'll explain later, that you can use for running fully production-ready workloads with Citus on Kubernetes. So let's look at how this was done before, how we were able to run Citus on Kubernetes to understand the complexity behind it, and then transition to how it could be done today and how much simpler it is. So for example, speaking of StackGres, Citus extension was added as an extension in already 2021, so a couple of years ago, right? StackGres in particular has developed a mechanism for loading extensions into containers that is very flexible. It allows you to essentially ship containers without extensions so that you have an increased security through not integrating into container hundreds and hundreds of potential extensions, and allows you to load them dynamically into the Postgres container by using a StackGres CRDs, or the web console for that matter. So you can load extensions, and Citus was one of them that was introduced in 2021. As far as I know, there's no other Kubernetes operators that includes the Citus extension. Now, adding the Citus extension is not enough. You had to perform a few steps to run Citus on Kubernetes. The first one is that you need to create a custom configuration, Postgres configuration. In StackGres, it's done by a CRD, a custom resource definition, essentially the API that on Kubernetes that you use, a custom YAML file, if you want to talk it that way, to create a custom Postgres configuration. I'll explain you why. Then you need to include the extension and refer to this configuration from the main CRD, the main YAML for StackGres, which is called SG cluster, which obviously creates a cluster. And then you had to run a lot, well, not a lot, but a few commands different on the workers and the coordinators, like UDFs, user-defined functions that are particular from Citus, to enable to build together the cluster together, right? This in StackGres can be automated also by the use of another YAML, another CRD called SGScript, but still you need to write all these pieces together. So basically, this is how it looks like, the SG Postgres config, the customized configuration for Postgres. There is typically two things that you need to do here. Well, this is a Kubernetes YAML. For if you're familiar with Kubernetes, this will be very usual. This is all documented anyway, and you can go to the website for documentation and check the syntax of these CRDs. But basically, you create an SG Postgres config, and then within the spec field, you specify PostgreSQL.conf properties. And here we need to specify two main ones. First one is to add the Citus extension to the shared preload libraries parameter for Postgres, and actually has to be the first extension in this list if you have more than one. The second one is that you can fine-tune Citus Gooks. Gooks is a configuration parameters that are specific, for example, to set up how you want the authentication to work between the cluster members. So here in this example, we are seeing that we are loading the Citus extension, and we are setting the SSL mode to prefer, which is one of the options to configure the communication between the nodes. So nothing out of the ordinary, not a big amount of work, but still something that you need to do manually. Then you need to add the extension to the SG cluster. SG cluster is the main YAML in StackGres to create a Postgres cluster, production ready with replicas, etc. And there is a section within the Postgres object called extensions, which, guess it, it allows you to load Postgres extensions. This is what I mentioned, that allows you to load them dynamically. And so that you can, any moment, edit this file, add or remove an extension, and it will be automatically loaded or unloaded from all the pods of the cluster that you're referring to. In this case, it's pretty simple. You can just say extensions in this array and then specify the name. You can also specify the version. Otherwise, StackGres will resolve it to the latest available version for the particular Postgres major version you're using, and it will annotate your CRD, so you can also later check on it to see what is the version that you got. And the last part is actually where you need to do most of the work, which is called the Citus UDFs. So these are Citus user-defined functions that allows the worker to be registered with the host, so with the coordinator to understand how to communicate with the other nodes. You also need to create the extension, the SQL command to create the extension, and you need to also configure the authentication between all the nodes. You need to ensure that all nodes are using the same password. Like, there's a fair amount of bit of work here. So basically, you can also create using StackGres and SGScript. Actually, you're going to need to create one for the workers, one for the coordinator or coordinators to use different, because you need to execute different commands on them, right? And well, it's not a huge amount of work, but it's something that you need to do carefully. Fortunately, you can automate all this into the YAML files. If you're a fan of GitOps approach, you can commit this to your repo, and you actually need to do this only once. But still, there's some amount of work and a fair amount of knowledge that is baked into this process. So to summarize, if you wanted to create a Citus cluster on Kubernetes before, you first had to create this SG Postgres config, the custom Postgres configuration file. You also had to create the SG scripts, one for the coordinator, one for the worker nodes. And then you need to create several SG clusters. You'll create one cluster for the coordinators and one cluster per shard. The reason why you want to create cluster per coordinator or per shard is very obvious. Is maybe you also want high availability. And the SG cluster will allow you to create multiple instances per cluster and set up high availability automatically between them. If you're more interested, here's the links. There is a RAM book written by a StackGres user, Dan Pretzelman, if I pronounce that correctly, that wrote these steps in a more streamlined manner. But fortunately, this is going to change, and it's going to become easier. So let's look at what Patroni 3.0, which was released, and Citus integration brought to the table, because this, as you will see, will make the process simpler. So essentially, of all the steps that you have seen, Patroni now by itself understands Citus and is allowed, if you configure obviously specifically for it, allows you to do the following. First of all, it will create the extension, run the create extension command automatically for you, and add it to the configuration and the shared preload libraries PostgreSQL configuration file. So you don't need to tweak the configuration for this, and you also don't need to run the create extension or create the database where you're going to run, you want the extension to be installed. And it also allows you to set the authentication parameters and run these UDFs that we mentioned for you. So in other words, and to make this very simple, if you use Patroni 3.0, also with Citus at least 11.2, and you set up the appropriate configuration within Patroni, then your cluster will be brought up essentially automatically. So the rest that you need to do is just to point and build the architecture, the infrastructure itself. But the cluster, if you provide the right configuration, will be built by Patroni itself. If you want to read more about this, there is a fantastic blog post announcement that is linked from the slides, and I would recommend you to check. So now, if we take these new capabilities of Patroni 3.0 and try to build them into StackGres, which is what we have done for StackGres 1.5, you get a much smoother experience. So let's look at how we can do this. StackGres 1.5, again, fully open source, also integrates Citus with Patroni 3.0. And on top of this, we're introducing a new CRD, a new YAML for Kubernetes called SG sharded cluster, which, guess it allows you to create a sharded cluster on top of Citus. And the idea is that this is a much higher level interface to describe a sharded cluster, that you don't need to go into the low-level details of this is going to belong to multiple clusters and how to configure Patroni. The idea is to hide all these implementation details behind a high-level interface. You're going to see how it looks like. So now, the steps to create a sharded cluster with Citus on Kubernetes by using StackGres are, first, create the YAML for the SG sharded cluster. And then optional, if you want, but typically obviously required, you may want to fine-tune the configuration. You can still create custom SG Postgres config CRDs to tune Postgres configuration, because very likely you don't want to use a default configuration, and probably you will want a different configuration for the coordinators or for the worker nodes. But it's still optional. So how this has been implemented, which is very interesting. We have used a pattern here called, or actually we call it, composing CRDs. So we already had the basic bits to create clusters in StackGres, the SG cluster. The SG cluster is the CRD, this YAML file that you write and will create a cluster for you. This cluster may contain multiple instances, high availability through Patroni, comes by default with connection pooling, comes by default with monitoring if you enable it, and a few other configuration details there. You can use custom instance profiles, which is the instance size. You can use custom configurations, etc. So we had these pieces already built in. And actually, the SG cluster itself doesn't generate the resources directly. It actually calls to all the Kubernetes objects, basically stateful sets, which also create the pods and the volumes. So to orchestrate all this, we just create metadata, the SG cluster. Now, we wanted to lean on top of this to create the SG sharded cluster. So the SG sharded cluster, in reality, is also not going to create directly objects. It's going to create the appropriate SG cluster objects that will, in turn, create the pods where you run Postgres. And this is shown in this graph that you can see in the screen. One important caveat here is that all the nodes need to share the same credentials, the same password. So one thing that we also did here is that the SG sharded cluster creates a common secret. And this secret is being referenced by every SG cluster created so that they use the same credentials. So as you see, this pattern of composable CRDs is very powerful. You as a user will only need to create the SG sharded cluster, and this will create the other objects that already in StackGres allow you to create Postgres clusters. How it looks like this YAML. This is the key. This is slightly simplified, but you will see on the demo that not by much. And this is a YAML file, very simple. What we're talking about here, 15 lines of YAML. Well, 15 lines of YAML will take you a long way because it'll allow you to create a sharded cluster with Citus in this just 15 lines of YAML. So here you need to specify an SG sharded cluster. And you specify on the metadata section the name, the namespace, and then under the spec section, you can specify the Postgres version, the type of sharding, which is now Citus supported, the database where the extension will be created, and then a section for the coordinators, one for the shards. Within the coordinators section, you can specify, first of all, how many instances do you want? One or more than one for high availability purposes, which StackGres will handle for you. You can also specify the type of instance that you want for those coordinators and customize configurations if you want to do that. And then under the shard section, you have the number of clusters that you have, the number of shards, consequently, and the number of instances per shard, because again, you very likely will want high availability. Then you can also customize the instance type and the profiles, the configuration and the instance type. And this is pretty much it. This YAML file will create all the infrastructure for you. So actually, I would like to show this working. So let's go to the demo. So here we have a few YAML files, which I will use to go through the demo, and we have a Kubernetes cluster created. So first of all, let's create a couple of metadata files, which in StackGres we call instance profiles. And an instance profile is no more than a t-shirt size or a definition of an instance CPU and RAM. You can also specify huge pages for more advanced configurations. So here, let's create one for the coordinator nodes, which just, this is a demo cluster, so just have a CPU, 1 GB of RAM, which should be more than enough. And we will just deploy this. Very simple, kubectl apply, dash F, and the instance profile. Oh, sorry, yeah. First, we need to create a namespace called Citus Con, because I'm referencing it from the file. Okay. And by the way, this is just an empty namespace, obviously, and there is an empty Kubernetes cluster just created with StackGres 1.5 installed. So I'll just apply this file, and it will just create it. And I will also create another instance profile for the workers. In this case, a little bit beefier. Well, not too much, to be honest, but enough to run the cluster on this demo mode. So let's just also apply this file, and this will create a second instance profile. All right. Then we will create a couple of customized Postgres configurations, one for the coordinator, one for the workers. We're not going to tune it very much. I'm just going to set the shared buffers to the canonical 25% of the RAM. So because they have different amounts of RAM, I will create different configurations, both for Postgres 15. And as you see, I'm not even setting any Citus parameters here. This will do Patroni called by StackGres integration. And the other one is 0 to B, which is pretty much the same, except for workers that have a little bit more RAM. So I'm having a slightly bigger shared buffers. So let's apply these files, A and B, and we'll have the two configurations created. We're pretty much done. Now let's look at how to create the sharded cluster. And as you can see here, the YAML file, okay, we're talking about, well, this one is a little bit more, 29 lines of YAML file, but not by much. I'm calling this COSG, Citus on StackGres, and the difference is that I'm specifying the Postgres version here, and then I'm defining the size of storage for the coordinator nodes, as well as a custom configuration that we just created, and also I'm specifying the coordinator instance profile. So I'm going to create 2 instances for the coordinator, and then I'm going to create 3 shards, which each shard is going to have 2 pods, so 2 instances also. And then the bigger size, and because yes, I'm running this on a whole environment, the same environment, 1 node, I'm just allowing pods to be created on the same node. So let's run this. It will take a little bit to run, but just a few minutes. So if we actually look on the Citus Con namespace, and here we have the pods are being created right now. This is going to be the coordinator one, and these other ones are going to be the pods with for the shards. While this creates, I'm just going to wait for a few seconds. You see, this will take approximately 1 minute, and we'll be able to run and verify that this is essentially a Citus database being created, Citus cluster being created with 2 coordinators. I mean, 1 coordinator role in high availability mode and 3 shards, each with 2 nodes, ready to be used. Whenever this is going to be ready, I'm just going to run this command exec. I'm going to run a shell here. I'm going to connect to the, sorry, what was the name of the cluster? We call it, yeah, COSG. So let's say Citus Con, COSG. We're going to connect to the coordinator and the container Postgres util, where StackGres contains a PSQL command, and I'll connect via PSQL. So here's a command to get connected here. And actually, there's a database here called, the database called Citus Con 23. So actually, I can just connect to Citus Con 23, and this will take me directly to this database. All right, so let's get to the pods. Let's see if everything is brought up already. We can see, yes, it took less than 100 seconds to build the whole cluster. You see there's 8 nodes. And actually, if we connect, we will see first that the extension is loaded here, Citus columnar. And if I check the nodes, there's this table in Citus called this node that shows that the primaries are all connected. From here, I could do anything you can do with the Citus database. I create a distributed table, insert data, it all works. We can see how Patroni works. But I'll finish the demo here today. Please keep an eye for future demos. So I'll just go back to the slides for now. And my last bits is that I would like to welcome you. If you want to know more about running Citus on Kubernetes or StackGres in particular, please join our public communities in Slack and Discord, slack.stackgres.io or discord.stackgres.io. You'll find the links. And just keep an eye on what we're doing, because there's much more stuff coming down the road to make it easier and easier to run Citus clusters for production on StackGres. All fully open source, both StackGres and Citus are. And so I really welcome you to join us to start testing this, to report, to help. And this is an open source community, so just join us and enjoy Citus on Kubernetes. Thank you very much for listening.